ask me to whether to overwrite. Okay. And let me get back to the class. So you could get into this part, right? We are currently on topic 2 already. And we talked about conditional statements. We are not done with conditional statements yet, but this is where we left off last time. So were you able to get to this part? No? Did you see one thing, or did you see a whole list?
I saw the first one.
Okay, so you saw this one. Did you see something like this?
I think
Like this? It only shows the first topic?
Yeah.
That's because you click this icon here. When you click this icon, it shows it will shrink everything down to one single topic, or if you click it again, it will toggle and show all the topics again. So you must have clicked that button. And if you click it again, it shows all the topics again. So you probably just have to click that again. There was another question a little bit earlier, like where do you find the video clips for this class? That was another question. You go to YouTube.com, and then you only have to type in this class name, which is cisp300, and the date of the recording. Let's say we want to locate the recording from Tuesday. Today is the 27th, so Tuesday is what? The 25th. So you just type in 2011-0125, press the enter key, and it's not there.
I think there is a space
strange.
between CISP and 300. That's how I find the class.
I might have forgotten, or I uploaded at the wrong day. No. Or I just have not uploaded.
25.
25?
25. Yeah.
We tried that already.
Yeah. No, there is a space.
There is a space?
There is a space between 300 and
No, those are not my recordings. I don't think on Tuesday we did any final battle, so that may not have been uploaded yet.
Then click search again, maybe it's fine.
Let me try my other class because no, that's not there yet. That is odd. Let me sign in and find out. Okay. Oops. Go look at my videos. Okay, so I did some on the 20th, and then this back to December. That is odd. I uploaded 2 really long video clips because YouTube told me that I can now upload longer video clips, so I uploaded the entire 80 minutes. On Tuesday night. It did not complain at the time, but somehow it did not make it to YouTube either. I'll look into that. Okay, I did not check, and obviously it was not working. So I'll go ahead and check on that, and we can also look at the longest sort by length, and it's not there either. So something happened, and it's not. Okay, I'll check this, but it's definitely not uploaded correctly, so I will check on that. Okay, any other questions before we get back to conditional statements? No other questions? Okay, let's start with the homework, your next homework assignment, which is also due in a week. We'll talk about the homework assignment first. We do not have all the pieces necessary to do the homework just yet. So basically, I will talk about the homework assignment, and for the next 15 minutes or half an hour or so, we will talk about the topics that you need to do the homework assignment. So I think in that case, you guys will pay more attention because it is directly related to the homework assignment. And the basic idea is about the same. You download and save this document. Except in this case, it is not just putting your name on sheet 2, save the file, and then turn it back in. In this case, you have to complete the traces. There are 3 traces you have to complete. One is in sheet 2, one is in sheet 3, and the last one is in sheet 4. They are based on the same algorithm, based on the same program, but you have to trace it using different preconditions. So there are 3 separate exercises rolled into one single homework assignment. And I would do the usual thing. You can either save it first, or you can open up with Calc right away. I will save it first. And open it from inside Firefox. Everything is going to be a little bit slower today because it's not running out of a flash card. It is running out of a CD-ROM. So there's a lot of seeking on the drive, which is part of the reason I switched from a DVD drive to an SD card. Not because it's slow, because I have been killing these DVD-ROM drives, for the past few years. Yep.
Is Calc the same as spreadsheet?
Calc is the spreadsheet of OpenOffice. That's just the name of the application. So if you have been using OpenOffice, you have been using the right application. And the first thing we want to do is to bump up the font size. This is the algorithm. We have not really talked about this yet. We touched on this on Tuesday, but we have not finished this part on Tuesday. And this is also an incorrect algorithm, but you will trace it nonetheless the way it is. So it may not behave correctly sometimes. The first test case is on sheet 2. On sheet 2, you have a precondition already defined, so you don't have to type your own precondition line. In this case, I give you w equals 2, x equals 3, y equals 5, z is unknown, and then you just go from that point on and trace the algorithm accordingly. Sheet 3 is almost the same thing, except w has a different value, and on sheet 4, w and x both have a value of 6. Okay, so that's your homework assignment for this week. Are there any questions about the homework assignment? What you have to do, how to turn it back in, and so on and so forth. No problem.
Trace it. Trace the algorithm.
Just trace the algorithm.
It's on sheet 1, correct?
The algorithm is on sheet 1. Yes. This is the algorithm.
So we can just bring up the other sheet 2 on a separate window and do it
Yep.
side by side?
That's the way to do it. What you do is, now when you're doing this at home, you probably do not need the font size to be that big, because in the class I need to make sure everybody can see it. So you can bring the font size down a little bit, or bring the zoom down a little bit. You go to Window, you click New Window. So now this is actually a second window. You have to click this icon here so it's not maximized and take up the entire screen. So now you can display both windows at once. And then you click on sheet 2, so now you can display the algorithm and work on the sheet, the trace at the same time. Okay. Any other questions about the homework assignment? Yep, go ahead.
We are going to be uploading it back up to the server.
Yes, just like with the first assignment.
Where do you want us to put our name?
Nope, you don't have. Well, you can save it under any file name if you that you want to. Because when you turn it in, you already authenticate in Moodle as you. So there's no. I don't need special file names to identify who actually did the work. Any other questions? No other questions? Okay. So if there are no questions, I will close this one. There's no need for me to go over this at this point in the class. Although I do need to pass the roll sheet just to see who is here today. And we can now continue to talk about conditions and also conditional statements. Hopefully, at the end of today, we can at least get into loops a little bit, because that's a pretty big topic too. And let's see, show only the screen. We are pretty much done with logical operators. The 3 logical operators that we have to understand are conjunction, which is and, disjunction, which is or, and negation, which is not. Those are the only 3 logical operators that we have to understand for this class. So now we are going back to the example. The example is going to give you an algorithm to find the maximum of 3 variables. And instead of using just if, else, and if, now we have a slightly different construct. We have the if here. Okay, let me just magnify this a little bit. We have the if just like a regular conditional statement. We have the else just like a regular conditional statement, and we have the and if. But we have something else in this algorithm that we have not seen before. We haven't seen else if before. Else if, once you have else if, this becomes a multi-branch conditional statement. In other words, we have more than one conditions to evaluate. Let me just describe the way it works right now, and then I'll give you a picture of what it looks like when you convert it into a pictorial, a graphical form. You still have to look at or read the algorithm from top to bottom. Okay, so remember that. Unless you have a loop that brings you back to an earlier point, which hopefully we will get to in today's class, you always read algorithms from top to bottom. So that means even though line 1 and line 3 both have a condition to evaluate, you always evaluate the one on line 1 first. On line 1, we evaluate whether w is greater than or equal to x and w is also greater than or equal to y. If that condition is true, we execute line 2 and then we jump all the way out of the conditional statement. If that condition is false, then we go to line 3 and then we evaluate the condition on line 3, whether whether x is greater than or equal to w and x is greater than or equal to y. If that condition is true, we execute whatever is on line 4. If that condition is false, then we fall all the way through to line 6. In other words, the word else on its own is a catch-all case. It is a catch-all case, which means if all the conditions before that, they're all false, then you go to the else case. Are there any questions about the order of evaluating the conditions? No questions? Yep, go ahead.
That's the question.
Yep.
So say the first case is false, but then not necessarily in this case, but the second two cases are both true. You take z x is z, right? Because the second case came first.
Okay, now that's a good question because you're asking the question from the perspective of a person. Okay, but when you run the algorithm, it's not the same thing. When you run the algorithm, you are going to evaluate the condition of line 1. If that is true, you execute a statement on line 2, and then you get out of the conditional statement. In other words, when you execute the algorithm, you would not even realize that the condition of line 3 is also true.
So it just like skips it, doesn't even realize.
Exactly. You skip that entirely if the condition of line 1 is true to begin with. Okay. Now this should become a little bit more clear when we look at the picture of that particular algorithm. And I think this is incorrect. Okay, this one actually matches your homework assignment exactly. Okay, so we'll just take a look at this one because it is still correct. It is still relevant, but it is not the same as the algorithm that we looked at a little bit earlier, because you can see that this one only has greater than instead of greater than or equal to. Okay, when you are doing programming, whether you specify greater than versus greater than or equal to, sometimes it does not make much of a difference. Other times it makes a lot of difference. Okay, but we'll just take a look at this one, and see, what does it mean to have the else if. Okay, you're still coming in from the top. Okay, the first question you encounter in this case is whether w is greater than x and w is greater than y. That's the first question that you have to answer. If the answer to this question is true, then you go to the left-hand side, the true branch. You execute this statement. Z is updated with the value of w, and then you exit all the way out. Okay, so are you getting a better idea now? It's only when the first condition is false, then you follow the false branch here, and then you ask the second question. When you ask the second question, it is the same thing. You have a true branch going to this part here, and then you have a false branch going to the other side. Is that okay? I mean, is that better? Explaining the way the things are evaluated a little bit better? Okay. Very good. So once we have a basic understanding of something like this, and based on the question that you asked, that was a very, very good question to ask. Let us go take a look at some really strange cases. Okay, there are strange cases where a branch is called dead. Okay, you have a dead branch in a multi-branch conditional statement. Let's go ahead and take a look at a very simple one. It's almost a trivial case, but I think you guys will find it kind of amusing that you can write programs like that and nothing will catch it. So we'll go ahead and write the algorithm and also trace it. The algorithm will start with something like this. Okay, if x is different from y, then we have some statements here. I don't really care at this point what it does. And obviously all my settings are gone because this is a fresh installation. So I have to go to autocorrect and just turn off everything except for the replacement table. So turn it off, 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 off. There we go. So z gets 1. I don't really care what this program does. And then we'll say else if x is less than y. Z gets 2. Else without the if. Z gets 3. And if. Do the indentation. And give it line numbers. Let's just take a look at this algorithm, and we'll go ahead and trace it under different conditions. Okay. And this is directly related to the question that you asked a little bit earlier. Okay, the first one is going to be a simple one. Remember, every time you have conditions in a conditional statement, you have to have a column for comments, because I want you to explain to me what is the result of evaluating a Boolean expression. Does it give you a value of true, or does it give you a value of false? So that's why we always need a column for comments in a program with conditional statements. We also need line number, and in this case we have 3 variables, x, y, and z. The precondition, which is abbreviated as pre, has to tell me the initial conditions. Do we know anything about x, y, and z before line 1 executes? That's the question. In this algorithm, I have to know something about x and y, because otherwise there's no way for me to compare and know which one is bigger or are they even different. So x and y, they need something here. And the first one, I'll just say, x has a value of 5 and y has a value of 3. I don't really need to know anything about z because I am going to override it anyway in the algorithm. So this will become my initial condition, or the precondition. Then I start executing on line 1. When I execute line 1, I know none of the variables is going to be affected. On Tuesday, I still use the longhand, which means I copy everything from row 2 to row 3 in the spreadsheet. Starting today, I'm not going to do that anymore. If there's no change, you just leave that cell empty. In this case, I leave this cell empty because x is not being changed. I leave this cell empty because y is not getting changed. I leave this cell empty because z is not getting changed either. So this way, you can kind of move along a lot faster because you don't have to copy values that have not changed. In the comments cell, on the other hand, I have to repeat the question itself, y is different from y, and then I have to indicate the result. Is it true or is it false?
It's true.
It is true. Very good. So the answer is true, and based on the picture that we looked at a little bit earlier, where should I go now?
2.
We should go to line 2. Very good. And line 2 does do something to z. It copies the constant 1 to z. Z is now updated to 1. And since we get out of the conditional statement after line 2, we just say post because there's nothing else to do in this algorithm. Are we doing okay so far with this? So this is the easy case. Let's go ahead and take a look at a slightly more difficult case. Or it's not difficult, it's just more tricky. Okay, so we still need a precondition, and this time we'll make x less than y. Well, let's not go there yet. Let's try another trivial case where they are exactly the same. Okay, so this is also a fairly trivial case, even though it will go through both of those conditions. We start on line 1. Line 1 does not change x, y, or z. Leave these 3 cells blank. I have to indicate the result of the comparison. X is different from y is false. Very good. And then where do we go? According to the picture, if the first condition is false, we have to go to the next available condition. On line, sorry? On line 3. Very good. On line 3. On line 3, we are asking another question. This time I'm asking x is less than y is
False.
also false. Very good. Let me go back here and just fix this a little bit. There we go. Then where do we go? We go to line 6. Okay? Line 5 is not incorrect. It's just that the else statement all by itself does not really do anything. As a result, I don't trace line 5. If you trace line 5 in your work, I will not take any points off. It's just that, typically we don't trace that line. So we go to line 6 in this case, and z gets updated to 3, and we are done. Are there any questions about the second test case? This is called a test case. We specify specific values to x and y, and then we try to figure out what is going to happen in this algorithm. Is that okay so far? Okay. Let's go ahead and take a look at yet another case. Okay, so this is the last one, but the last one is the tricky one. When you use Open Office Calc, when you paste special, and I think there's an option to also paste. Oh, I guess not. You can also paste the formats sometimes, but not in this case. Okay. In this case, I'll use a precondition, and this time the precondition will state that x is less than y, because this is the trickier one. And I will also tell you guys how to approach, tracing an algorithm like this. Okay, now you take a look at the precondition. X has a value of 2, y has a value of, x has a value of 0, y has a value of 2. And the trick to trace an algorithm like this is not to think about the algorithm like a person, but instead you want to execute a program step by step, just as the computer would. Okay, that's the key. Sorry?
We make it the same as the first one because the first one is true, and so
Exactly, because now on the other hand, if you don't look at it that way, if you don't look at this from a computer, I'm just a computer or robot, doing things in a very sequential manner, and you look at it from a person's perspective, then you end up with a problem, because there are 2 conditions that are true at the same time. The condition of line 1 is true because x is different from y. 0 is different from 2. You look at line 3, that is true as well. X is less than y also. So if you look at it from that perspective, which is a person's perspective, then you will start to wonder, okay, so which way do I go? Should I execute line 2? Should I execute line 4? Should I execute line 2 and then line 4?
just execute line 2 because when you just
Exactly.
in the computer order of operations, just
That's why you have to.
right?
That's why you have to pretend that you are just a computer and you are only doing things in a sequential way. You do not look ahead. Okay, you don't look at line 3 until you have to look at line 3. So knowing that, we will start with line 1. That's the key. Start with line 1. Line 1 says x is different from y is true already. So that means we go to line 2. Line 2 will update z to 1. And what do we do after line 2? We go all the way to post. Okay? We go all the way to post, even though the pseudocode may seem to suggest that there are more things to do. But if you look at the picture of a multi-branch conditional statement, after you perform the action that is correlating to a condition, you go all the way out. You don't go back and ask the next question. So remember, you have to map the syntax of pseudocode to the picture at least for a few times when you do the homework assignment until you get the idea down. Then you will not execute the other branches. So I'm glad you asked that question. That was a very good question. Okay. So is this example illustrating the whole idea? Now remember I said there was a dead branch in the algorithm. Where is the dead branch?
Z is 2.
Z gets 2, or line 4 in this case, is our dead branch. Because under no condition, we will actually go to line 4. Regardless of the values of x and y, there's no way we can go to line 4 in this algorithm. Okay? Now this is something that is really hard for the compiler to catch. You can write a program like this and have the compiler to analyze your program, and it is really difficult for compilers to realize that there are certain conditions that can be true, that there are multiple conditions that can be true at the same time. But when you look at this from a person's perspective, it looks kind of like, yeah, I don't see anything wrong with it. Now this is somewhat obvious, but what if the condition of line 1 and the condition of line 3 are this long? Because you're writing a program to implement the logic of, say, TurboTax. Okay? So there are cases where you can actually end up with a situation like this. The program seems to be right, but it can behave incorrectly. Now in this case, let me just give you another exercise. If I change the order of the condition, so I put this condition on line 3 up to line 1, and then I put the condition of line 1 down to line 3, do you think that will change the behavior of this program?
Yes.
It will change the behavior of the program, and there will not be any dead branches anymore. Okay? So when you're dealing with a multi-branch conditional statement, you have to think about all these things, because you can end up with a dead branch in some cases, and in other cases, changing the order of the conditions can change the behavior of the conditional branch, the conditional statement. So be very careful when you use constructs like this. Are we good to go? Okay. So I'll go ahead and save the document, and I have to go find out what happened to the video clip on Tuesday. I don't really have a flash drive with me today, so it makes it kind of difficult to save it. Let me think about how to do this. I'll save it anyway. Hopefully at the end of the class I will remember to upload it right away. So 2011-0127. Okay. Okay, language issues, it's basically just looking at pseudocode and say, why do we need an and if at the very end? Well, the first reason is and if is actually used in some programming languages. Visual Basic has and if. In other words, this is for the most part exactly the same as how you would say it in Visual Basic, except you don't have the not equal to comparison, and you replace the left arrows with a equal symbol, because in Visual Basic, a single equal symbol means assignment. But otherwise, the syntax is exactly the way you want to specify in VB, in Visual Basic. In C, it is a little bit different, because in C, well, when you get to cisp300, you will see how kind of confusing the C syntax is. In C, after the if, it will only allow you to specify one statement as the thing to do, as the action to do when the condition is true. After the else, it will only allow you to specify exactly one statement also to specify what to do when the condition is false. But that's it. In C, it is difficult to express something like this. When there are two things to perform, two actions to perform when the condition is true, you have to use the curly braces in order to create a block, and the entire block will execute when the condition is true. So this is something that is extra. I will not test you on C constructs, but when you move on to the cisp300 class, just make sure that you pay attention to multiple statements to perform in a conditional statement, because you have to use curly braces in those cases. Whereas if you only have one statement to perform, you do not need curly braces. I always put in curly braces just so that I know that I will not be, I will not be caught by problems like this. We are done with conditional statements. Do you feel confident you can get the homework assignment done at this point? Have I covered enough topics? Yes, go ahead.
Can we trace it just like you did, so if it doesn't change, can we leave it blank? Or do
Yes, you can use exactly that convention, yes.
Okay.
Yeah. I would prefer that you guys do that too, because it actually is a whole lot easier to read from the grading perspective when you don't copy all the values down. Yep. So now we are done with conditional statements, and we are going to move on to loops. Now this is obviously just, I was just having fun with, writing the topic of this section here. What is a loop again? Why do you think that's a play of words, that is actually in the right context?
Like I said before,
Because it is a loop all by itself. Okay? What is a loop again? The word again implies you're trying to do something all over again. You're going to an earlier point to try to redo something. Okay? So that's the essence of a loop. A loop is a control structure that permits certain steps in a program to be repeated. Without loops, programs cannot perform steps over and over again, often without knowing exactly the number of times to repeat. In real life, we all rely on loops as well. Okay, I'm pretty sure most of you have performed some sort of loops just a little bit earlier today, finding an empty spot in the parking lot. That's a loop. And it's also a loop where you do not know how many times you have to repeat before you can actually find a spot to park. Is that right? So that's a loop. And we have a lot of loops in real life. Every time you tell someone or you tell yourself, okay, I have to keep doing this until something is true, that's a loop. Okay? Or anytime you say, as long as blah, 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 do something, that's also a loop. Okay? So we'll go ahead and take a look at loops in this case. The first loop that we take a look at is called a repeat until. And this is just an example, which is actually a bad example. And I explain later on in the notes why this is a bad example. So the example is, repeat, take a bite until that person feels full, and then everything is all done. Okay? But what does it mean exactly? That means you first have to start with taking a bite. You don't even ask a question, you take a bite first. And then you evaluate the condition. Is this person not hungry anymore? If the person is still hungry, which means this condition is false, you go back and you take a bite again. And then you ask the question again. If the condition is false, you go back and take another bite. So you keep doing this action, question, action, question, action, question, until the answer to the question is true. Okay? When the answer to that question is true, then you get out of the loop. I know the English version or the verbal description of this is somewhat confusing, so it is best to show you a picture that represents the same logic. Now, this logic is very tricky because when you first come in, which is from the north, we always come in from the top or the north, you don't ask a question. You go straight to the action itself. After you perform the action, then you have two branches. You can either go for this branch here, going back, or you can go for the branch that gets out of the entire loop. The way you decide which way to go is to look at the question, and you answer the question. The question has two possible answers. It's either true, which allows you to proceed to the next statement, or the answer is false, which will ask you to go all the way back and perform the action again. And that's why this is also called a post-checking loop, because you are checking the condition after you perform the action. You always perform the action, and then you ask the question. Are there any questions about this picture? It is also important to realize that these are all unidirectional paths. In other words, you can come in from here, you can also come in from here, but you cannot come in from here and exit right away because this is a one-way street. Whenever you look at a pictorial representation of an algorithm, you're always looking at one-way streets. Are there any questions about that part? Because if you don't remember that you're looking at one-way streets, then you might think that sometimes I can come in here and decide to get out right away without going through the action even once. That cannot be true for a post-checking loop. Any questions about this? No questions? Let's go ahead and go through, do one exercise just so that we know how to deal with this in an actual program. Okay, so we'll go ahead and make one really, really simple. X gets x plus 1 until x is greater than 3. And I'll give you the initial condition. So once again, this example is not in the notes. Okay, it is actually something that I talk about today. If you think that I may forget to save this file and upload it, you might want to just write it down on a piece of paper, just so that you have that example on record. Okay. I also need a column for comments in this case, even though there are no conditional statements. There are no conditional statements, but when you look at this algorithm, there's a condition. Because on line 3, I have a condition to evaluate so that I can determine whether to get out of the loop or whether I have to go back and perform step 2 or line 2 again. So every time you have a condition to evaluate, you have to specify a comments column. And the next thing we have to do is a line number. Okay. And then we have one single variable in this case, which is x. Let's start with a value of 0 as our precondition. Okay, this is the first test case. So in the first test case, it's not too difficult. Just want to show it like this. Which line should I begin with? We should begin with line 2 because line 1 does not really serve any purpose other than marking the beginning of the post-checking loop. And we don't trace lines that do not really do anything useful. So line 2 is the first line that we have to trace because line 1 doesn't do anything. When you submit your trace and someone turns in and that person traces line 1, 2, I will not mark it wrong. It's just that it is not necessary to indicate that you start with line 1 in this case. We start with line 2. X goes from 0 to 1. You remember, this is an assignment statement. You evaluate the right-hand side, and then you update the left-hand side. And then we go to line 3.
Don't you put your comments of line 2, x plus 1?
No, line 2 does not need comments because we are not evaluating a condition. You can if you want to. You can add additional comments if you want to, but it is not necessary when you turn in the homework or answers to a question in an exam. On line 3, we don't have a choice. We have to ask the question and then indicate the answer. X is greater than 3 is false. Very good. Okay, where do we go? I know this is telling me to go one way or the other way. If you don't remember which way to go, you can always go back to the picture, which shows you if the condition is false, you go back to the first step, to line 2. Yes, go ahead. Yep, to the second line. So we go back to the second line, we execute that line again. It goes from 1 to 2, and then we go to line 3 again. We re-evaluate x is greater than 3, 2 is greater than 3 is still false. We go back to line 2, this time it goes from 2 to 3. We go to line 3. It is still false because 3 is greater than 3 is false. We go back to line 2. Now this time we bump it up to 4. We go back to line 3. And this is finally true. So let me change that. When the condition is true, you get out. And since we don't have any more statements after that, we just use post to indicate this is the entire trace we are done. Are we good on this? Now, if you look at the condition x is greater than 3, we get out of the loop when that condition is true. And that's why that condition is also called a exit condition. Okay, it is also called an exit condition because when the condition is true, we exit the loop. Okay, that's one test case. Let's go take a look at, say, another test case. Okay, the other test case is a little bit tricky. In this case, we'll start with a precondition, and this time I will start x up with a value of 3 to begin with. This is tricky, but not as tricky as the next one. The next one is going to be just a little bit more tricky. We still have to start with line 2. Line 2 will immediately bump x up from 3 to 4. Then we go to line 3. Line 3 will say, what is the value of x? It is 4. 4 is greater than 3 is true. We get out, and we're done. In other words, we go through the loop exactly once. Okay, let's take a look at yet another test case. The next test case is going to be the trickier one, because in this case, the precondition is x already starts with a value of 20. Okay? So once again, when you look at this from a person's perspective, in other words, a person does not execute or read something line by line. You know, we all have the ability, and whether we want it or not, the way we read things is we glance. Okay, we can read multiple characters on the same line, and we also read multiple lines at once. And as it turns out, in this case, that may not work to your advantage when you read multiple lines at once. Because when you look at the precondition, x is already 20, and you read multiple lines at once, you already glance through the algorithm, and you realize that you have to get out of the algorithm when x is greater than 3. But it is not correct to say that, oh, we just have to go straight to post. We cannot. Because remember, you have to follow the rules when you execute an algorithm. When you execute an algorithm, you have to look at the picture and go, oh, we don't have a choice. We have to perform the action of the loop before we even ask the question, should we go back and do it again? So that's why when you trace this algorithm, you have to go to line 2, regardless, because you don't have a point of branch until later. And that means x will increment to 21. And then on line 3, you evaluate the condition, x being 21 is greater than 3 is true. Then you can exit, and then you call it a day for this algorithm. Are we clear on this part? Okay. So remember, you have to read the algorithm line by line and execute the algorithm line by line. Reading ahead may not be useful or desirable when you're tracing an algorithm. Are we doing okay so far? How many people think that, there's just too many rules and too restrictive, and these rules are not reasonable? I don't really like this. Well, it's not whether we like it or not, because this is exactly how the computer will execute when you specify an algorithm like this. In this class, my focus is to make sure that you guys understand exactly how the computer is going to execute an algorithm so that you know what the program is going to do when you move on to CISP360. That's the focus of this class. And that's why we have all these little rules. They may seem kind of odd, strange, and not really natural, but that's the way the computer is going to behave. And you have to understand how the computer is going to behave. Are we good on this one? Okay, so let me save this file. And we'll give it a little suffix. Okay, well, the next title is this all worthwhile? Because we are going to talk about a while loop. Okay? A while loop looks kind of like this. Okay? If I want to do almost the same thing as last time, but using a while loop, then the loop becomes while one is still hungry, do, take a bite, and while. Okay? If you're not used to the word while in the context of a loop, change while to as long as. Okay? Because when you change while to as long as, it means exactly the same thing, but I think you will have a better association of what it actually means when you execute the algorithm. It looks like it's almost the same logic. While one is hungry, do take a bite and while, as opposed to repeat take a bite, until one is not hungry. Okay, they seem to express exactly the same logic, but it is not the case, because in this case you ask the question first. In other words, this is what we call a pre-checking loop. You ask the condition first. The picture of a pre-checking loop turns out to be a little bit more awkward. Okay, this is starting to look like a biology class, except fortunately we don't have a loop in our digestive system, unlike some other animals. Okay, so in this case, when you look at this picture, it looks a little bit confusing. But remember, every path is unidirectional, which means it's a one-way street. So you have to remember, when you come in here, this is a one-way street. This is a one-way street. This is a one-way street, and this is also a one-way street. When you first come in, you ask the question. If the answer to the question is true, you perform the action, in the loop. If the answer to the question is false, you get out of the loop like this. Okay? Now, let's just say that the answer to the question is true. You perform the action. After you perform the action, you follow this arrow. You go all the way back to this point here, which is before the branch, before you have to make another decision. Then you drop down to here, then you ask the question, then you decide which way you want to go. Are we doing okay with the mechanism of a pre-checking loop? It's just a little bit uglier than a post-checking loop, and it works a little bit differently.
The opposite of a regular loop being that you're asking the question until it's false instead of true?
From that perspective, it is, kind of the opposite, yes. But it also asks the question first instead of last. Okay. So are we okay with this picture? Because if we're good with this picture, I'm going to use a real example to illustrate, the mechanism of a pre-checking loop. We'll go ahead and make another spreadsheet. You can see that, we use a lot of spreadsheets in this class. So this time I'll use something kind of like last time. It's not the same thing, but it just looks about the same. Okay. And we'll go ahead and have a few test cases out of this algorithm here, which is really, really simple. This is a very simple algorithm. But the form of this loop here will be seen again and again in this class, pretty much all the way through to the end. Open a new window for the trace. And we'll set up multiple test cases just so that we know what it will do with x starting with a different value. We need one column for comments because we do have a condition to evaluate on line 1, and that determines which step we're going to take next. So that's why we need the comments here. We need a line number and a single variable x. So we'll go ahead and get started with a precondition. Let's start with something simple. Let's say that x starts with a value of 0 to begin with. Can someone look at this algorithm and just right away tell me how many times we'll go through line 2?
4.
No.
3.
It's 3 times. 3 times exactly. Okay? And that's why I asked the question knowing that this class may not know exactly how many times it will go through just because of eyeballing it. And that's basically telling you that in a class like this, it is usually good to trace the algorithm just to find out exactly how the program is going to behave. In this case, we start with line 1. But how can we trace line 1 in this case but not in the previous case?
Because it's an evaluation.
Because there is an action to perform. We have to evaluate the condition. Very good. So in this case, we have to evaluate the condition. The condition is x is less than 3. It is true. X is 0. 0 is less than 3 is true. Okay. So let's go back to the picture and say, okay, the condition is true. Where do we go? we go to the action. Okay, we go to line 2. Very good. So we go to line, oops. We go to line 2. Line 2 is not doing anything that's too complex. It's an assignment statement. We evaluate the right-hand side. X has a value of 0 at this point. 0 plus 1 is 1. We use the right-hand side to update the left-hand side, which turns out to be x again. So x is now updated from 0 to 1. And then what do we do? Back to line 1. Very good. Okay. The most common mistake that I have seen with this kind of statement is someone would accidentally equate this to a conditional statement because it looks kind of like a conditional statement. You know, the condition is at the beginning, not at the end, and you specify statements in between. But it is not a conditional statement, and as a result, we don't go to post. We don't go to post right away. We have to go back to line 1, and then we may go to post. Okay, this is a loop. After you perform the last step before end while, you have to go back to the while line to evaluate the condition of the while line. So we have to go back to line 1. We ask the same question. But just because the question is the same does not guarantee the answer is the same. But in this case, it is the same because 1 is less than 3. Then we go to line 2 again. We go from 1 to 2. We go back to line 1. X is less than 3 is still true because 2 is less than 3. We go back to line 2. X is now updated to 3. We go back to line 1. X is less than 3 finally is false because 3 is not less than 3. Then we just say post. Okay. Now, if someone gives me a post on row 9 of this spreadsheet, I will mark it wrong. Okay, let me say that again and point to the place where I'm supposed to go. If someone move this post up to here and not give me this condition here, that will be marked wrong because you cannot get out of a loop unless you evaluate a condition. So in this case, you cannot get out of a loop on after line 2 because you have to go back to line 1 to ask that question again, and then based on the answer of that question, you can now get out of the loop. Okay, so in this class, I am very, very picky about stuff like this. So missing that one last evaluation of the condition will result in getting marked at least partially wrong. I will not take all the points off, but I will mark it wrong and take some points off. Are there any questions about this? Yep.
If we read it like 3 is not less than 3, that would be true in our perspective, but we don't in a computer. It's not read like that.
3 is less than 3 is false.
3 is not less than 3.
3 is not less than 3 is...
Can it also be true?
3 is not less than 3 is true.
Also too, but is that how we read it?
Well, you have to read the program exactly the way it is written.
Yeah,
in this case, it has to evaluate whether x is less than 3 or not. So when you submit your answer like this, you have to turn it in exactly this form. Okay, you have to tell me what the condition is and what is the result of evaluating that condition. Okay, I understand what you say. You're saying, can we write here and say x is not less than 3? And the answer is no, because I want to know this result here. That is the key, because when the condition of the while loop is false, you get out of a loop. Okay. Any other questions about this trace? This is the first test case of this algorithm, so we'll have more. This time I'm a little bit smarter. I can paste more than one cells at once. Oh, no, that's not what I meant. I knew something bad is going to happen when I selected multiple columns. Undo. Okay, so let's try it again. It's still there. Okay, let's see. Delete columns. There we go. All right. So this time let's start with, something that is tricky, but not too tricky. Let's start with a value of 2. I think most of you will know what this program is going to do, but let's do it anyway. On line 1, we evaluate the condition. x is less than 3 is true because 2 is less than 3. We go to line 2. It bumps up the value of x. It goes from 2 to 3. We go back to line 1. 3x is less than 3 is now false. And then we get out. Is that making any sense? Is that good? Okay. So that's our second test case, which is a little bit tricky because it only goes through the loop once, exactly once. Now you can also see that even if you go through the loop exactly once, the condition is evaluated twice. Okay? So the number of times you evaluate the condition is exactly one more than the number of times you go through the loop, because you have that last one that evaluates to false. Now let's go for the last one, which is the trickier one, but I think you guys cannot be tricked by that anymore. Okay, so we'll start with 3. Okay, x starts with a value of 3. So let's see what's going to happen in this case. We go to line 1. X is less than 3 is evaluated. It is false to begin with, and we are done immediately. Very good. Okay? Very good. So I think we have a good understanding of the pre-checking loop as well as a post-checking loop. Are we doing okay so far with the two different types of loops? Okay. Let me save this file. And just go back to the notes, in case I forget something. Repeat no more. Well, when should we use a repeat until loop, and when should we use a while loop? In other words, when do we want a loop to ask the question after the action, and when do we want to have a loop that will ask the question and then perform an action? Forget about this for now. Let's think about the logic of channel serving, okay, which we all do. Okay, so the logic is, okay, if you're watching a channel that you don't really like, you think it's boring, it's too violent, or just too boring, or it's not something, too many commercials, and whatever reason you don't want to watch it anymore, you press the up channel button to go to the next channel, and then guess what? You evaluate that channel using the same criteria. No, this is not what I want to watch. Up channel again. So you keep doing this until you find a channel that you want to watch, right? Okay, so that's the basic logic of channel serving. The question is, should you use a pre-checking loop, or should you use a post-checking loop to express that logic? That's the question. What do you think? Okay, why do we want to use a pre-checking instead of a post-checking? Why don't we want to say repeat press up channel button until I like that channel? Yep.
Because you're evaluating the channel that you're on first, and then you check and see if you like it. And
Exactly.
Then you change it, and you evaluate it again.
Yeah, exactly.
You have to evaluate the one you're on first.
Exactly. Now, just to make this kind of obvious why you don't want to do a post-checking loop, let's just say that you have cable subscription, and there are 600 channels. Okay, out of the 600 channels, there's one that you like, and that's the one that you're on before you run the algorithm. Okay, now you guys laugh because you already know what's going to happen, right? Because it is the channel that you like, but according to the logic of a post-checking loop, guess what? You have to press the up channel button. Unfortunately, the other 599 channels are not to your liking. So you have to cycle through all 600 channels to get back to the one to begin with that you liked, and then you can get out of the loop. Now, when you try to express the same logic using a while loop, using a pre-checking loop, then it becomes while I do not like this channel, do press the up button. If the first channel that you're watching is the one that you like already, oh, I like that channel. You skip the entire loop, you move on to something else. Make coffee, make popcorn, whatever. Okay? So that's why it makes a huge difference in that case. You have to ask the question first, because maybe the condition is already met to begin with. Is that making any sense? Okay. So the next thing, and I can already tell you right away, 90 or at least 80% of the time when you have to specify a loop, it is more appropriate to use a pre-checking loop. I can tell you that part already. When you write an algorithm, when you have to invent or design your own algorithm in cisp300, and you know that you have to use a loop and you don't know which one to use, chances are you have to use a pre-checking loop. The only time we use a post-checking loop, like this one, is in cases like this. Okay, look at this logic here. This is an interactive program, and what it does is it will keep asking for a zip code. If you give it a wrong zip code or an invalid zip code, it will ask you again. Okay, your zip code is incorrect. It is not valid. Please input a valid zip code. This is the only time when it makes sense to use a post-checking loop, and that's because the action you're performing in the loop is the action that will make the question meaningful. Okay, am I making any sense here? Think about this. If I flip this logic and use a pre-checking loop instead of a post-checking loop, it becomes while the zip code is invalid, ask for a zip code and while. But what is the first zip code to evaluate whether it's valid or not? It's not something that the user tells me. It is some zip code that existed in a variable before I started the algorithm, right? So that's why when the question itself cannot be meaningful unless you perform an action first, then it makes sense to turn it into a post-checking loop because the action is what prepares the question itself. Are we doing okay with this part? But the frequency of this kind of logic is far less than the frequency of the logic where you should evaluate a condition before you perform the action. Okay, so keep that in mind. While loops are far more useful when you write programs than the repeat until loop. And the rest of this talks about how in C we don't really have repeat until. Instead of repeat until, we have do while loops. Instead of while do, it is do while. This is a post-checking loop. In other words, in this case, we ask for a zip code first, and then we evaluate the condition. But the polarity of the condition is opposite to the repeat until. Because in this case, remember, every time you see while, you can equate it to as long as. So in this case, it is do, ask for a zip code, as long as the zip code is not valid. Okay, so that's why when you use a while instead of until, you have to flip the polarity of the question, because one is an exit condition. When you specify until, you specify an exit condition. When you use while, you're specifying a condition to stay in the loop. So that's why the polarity is opposite.
What does do mean? What does do mean?
Do is just a keyword to indicate that the following is a loop. This is actual C code. This is actual C code, and you have to indicate to the C compiler and say, oh, the following is actions that may have to be done again and again. And that's why you need do as a special keyword so that the compiler knows, oh, I know what to expect. I know I'm expecting statements to perform, and then followed by a while, and then a condition to specify whether I should do it over again or not. Okay, that's a good question. Okay. So we are done with loops as well. So now we have knocked like 3 of these topics away. We are done with variables, expressions, and sequences. We are done with conditional statements. We are also done with loops. And the next one is nested statements. Nested statements is also called hierarchical statements. There are many names you can refer to this. And let's see, we'll open up this frame only. Okay. You can read this part here. The text of my writing is kind of boring. In order to explain why we have hierarchical or nested statements, let me just ask you one question that is not related to algorithms. Would you like to have a file system, okay, FAT32, NTFS, whatever, that does not allow the existence of folders, subfolders? You get C:\/ as one root folder, and that's it. You cannot create any subfolders. That's the world without nested statements. Okay, what is so bad about having one single folder to contain all your gazillion files? It's not organized anymore, right? And it's the same thing with programming. If you write a program like that without nested statements, that means you have so many things to do at one single level that it is difficult to see, difficult to understand. And the second thing is you will not be able to express certain types of logic. In other words, sometimes we want to have a loop inside a conditional statement and inside another loop. Sometimes we want to have a statement, a conditional statement with a loop in the inside, another statement in the inside, or another conditional statement in the inside. And we have examples in this case. I don't think we have to trace this one anymore because we have seen this just about half an hour ago. So there's no way we have to trace this one. But to talk about this one, we have to talk about this one. Because guess what? This is already a nested statement. Line 3 is nested in between line 2 to line 4. In other words, if I have to count the number of statements here, there are several ways to count it. Let me project it on the whiteboard instead, so I can use different colors to indicate the different types of statements. How many statements do we have here? Well, we have one statement, that's an assignment statement. We have two statements, that's also an assignment statement. But we also have a while loop here. A while statement is also a statement. That's basically this part here. So technically speaking, we have 3 statements in this algorithm. It's just that the while loop as a statement contains the other statement, which is line 3. Are we doing okay here? That means every time you look at a conditional statement, you give then else, and every time you look at a repeat statement, every time you look at a while statement, they are like folders. They're just like folders in a file system because they can contain additional statements. In fact, most of the time, they should. If you have a loop that has no statement inside, if you have a conditional statement that has no statement inside, you should ask yourself, why do I need the loop, or why do I need the conditional statement to begin with? So are we doing okay in terms of the overall concept of nested statements? The only type of statements that we have talked about up to this point that cannot have anything nested in it is what? We have only talked about 3 different types of statements. Go ahead. Assignment statements. Assignment statements are the only statements that cannot have any nesting. In other words, you cannot have a conditional statement or a while loop or another assignment statement inside a assignment statement in pseudocode for this class. But that changes when you move on to cisp360. In cisp360, you can, in fact, nest stuff inside an assignment statement, which makes things kind of confusing. Okay, let me just give you a really confusing, example, just to show you what kind of stuff you can do in C that you cannot do in this class. This is just a plain text editor, so I'm typing out a C program, just basically the same way as it should be typed. You can say x equal to y equal to 0, and then the whole thing plus 1. Okay, so let me bump up the font size because I know some of you cannot see it in the back. So we go to font and color, change the font size to 15. That should be good. There we go. This is completely valid in C as a statement. Well, but it's weird, right? I mean, we have an assignment. Remember, in C, the assignment operator is the single equal symbol. In other words, this is an assignment statement. By itself, it will evaluate the right-hand side, which is 0, and then it will update the variable y to 0. Okay? That's a regular assignment statement in C. But it is a part of the expression, which is the right-hand side of another assignment statement, because the outer assignment statement is this part here. So that means one thing. That means the inner assignment statement, which is this one here, has to give you a value so that it can be added to 1. Can anyone guess what it is going to give you as a value to add to 1? It's 0. Okay? So this will update y to 0 first, and then it will update x to 1. Okay?
If y was 2, then x would be 3, right?
Sorry?
So if y was 2, then x would be 3. Right?
If that 0 is 2,
X
then
would be 3.
then y will get a value of 2 and x will get a value of 3. Now, since you guys most of you are moving on to cisp360, I'll just describe this one thing, and just so that you know that you can do it, not highly recommended, but you can do it. You can take this entire assignment statement, and you can compare that to Z, and then have a conditional state, and have the entire thing as the condition of a conditional statement. That makes things really, really confusing. Okay? In C, you can do things, you can do really, really confusing things that you cannot possibly do in this class in pseudocode. My recommendation is don't do those things, okay? Don't try to save 1 or 2 lines of code and just try to, oh, I can do this and combine 2 lines into 1. Don't do that, okay? Because in the end, your program will be, you will feel really good, you will feel really smart when you just do it, and then 3 days after that, you look at your own code, and you go like, I don't know what I did, and I don't feel so smart anymore. Okay? I know that because I have done that. Sometimes I do things just because I can, and then a few days later, then I realize, now I understand why I should not have done that. Okay? And so this one is easy, but it already has an element of nesting. So what you should do, because we are running up, against, the time limit for this class, what you need to do is to read this section here, which is a more complex example. Now this one is not quite as complex as it can be, but it's enough for this class. We have a loop going from line 3 to line 11, and then inside that loop we have regular statements, regular assignment statements like line 4 and line 9. But also, we have another while loop, line 5 to line 8, inside the outer while loop. So what you need to do is to go through this note here, make sure you understand this. It has the answer. Okay, if you want to find out exactly what happens when this algorithm executes, it's already here. In fact, there's also a big, nasty picture of the actual logic of this program, but expressed as a graphical form. And after this, we have a trace. It's a partial trace. It does not finish the whole thing, but it does illustrate all the important points. So what you need to do is to read this, make sure you understand this before next Tuesday, and work on the homework assignment. Because on next Tuesday, we will go through this example. I will explain it, but if you have read the material already, then it will make it so much easier. I'll see you guys on Tuesday. Have a nice weekend.